Okay, optimization problem again, this time optimizing volume. A piece of sheet metal is 60 centimeters by 30 centimeters. It is to be used to make a rectangular box with an open top. Okay? Determine the dimensions that will give the box the largest volume. Alright. So let's create what we had again. We have a piece of sheet metal, which means this is a two-dimensional shape right now. And the sheet metal measures 30 centimeters by 60 centimeters. It is to be used to make a rectangular box. What that means is they're going to fold up corners. Okay? And this is a hard thing to visualize, especially if you've never made a box out of a flat piece of paper. If you're going to do this, you need to fold up one end. Okay. And we want this to be a symmetrical box, so we're going to fold the other end, and it's going to be the same distance on both of them. Okay? So the distance of this, we don't know what it's going to be, so we'll call it x for both of them. Well, again, in order for this box to be flush all the way around, we have to fold the other ends also. And we have to fold the other ends by the same amount. This is not, what's the word? To scale. That's what I'm looking for. This is not to scale to what the answer is going to be in terms of the folds. I'm just trying to make them look somewhat similar. Okay? So think about this in three-dimensional space. When I fold this, this also needs to be the distance of x, or in other words, the same as we fold the widths. Okay? When we fold these up, these corners here are going to be left over. In other words, they're going to be extra to make sure they're not sticking out or in the way. We actually have to cut them off. Okay? I really feel like I should get you all to get paper and fold this up. Get a piece of paper at home, try this. Fold the paper up, fold the paper up. You'll realize you're going to have to cut the corners off to make a flush box that's the same height. Okay? So in other words, what we're creating is something like this. Talking about three-dimensional space again. Okay? Our box looks something like that. But this box has no top to it. Okay? So we've now folded it up. Here's our box. What that means is, because our variable or the folds were going to be the height of x in this, okay, that's what we said. This is going to be a height of x. That means these folds are the height of x, which then means the distance of the width of this is 30 subtract, well, this is x, and this is x. So 30 subtract x minus x, or in other words, 30 subtract 2x. That's the width of this box we're creating, which then means the length of it is very similar. It'll be 60, and because this is x and this is x, they fold up to make the heights. It is 60 subtract 2x. So that is our length and our width, and we know the height of this box because we're speaking of volume. The height of this box is x. Okay, so we have 60 minus 2x, and then over there, that should be 30 minus 2x is what we have. Okay? So again, zoom out. We have our volume, and we're trying to maximize this volume with this shape here. We need to figure out what the parameters of this are going to be. Okay? So if volume is equal to the height times the width times the depth or length, whichever you'd like to call it. Well, our height is x in this question. Our width, we're going to call 30 minus 2x the width. And our length is 60 minus 2x. Okay. Now we need to find out, again, we multiply these, we're going to have a large equation. We need to figure out what the parameters or the restrictions are going to be on this. Okay. In other words, I need to set each of these equal to 0. In other words, we're looking for volume at 0. We know we can't be less or greater or less than 0. We need to be some number larger than 0 in real life to actually have some type of volume. So to solve this, because of the associative property, it doesn't matter which of these is 0. If one of them is 0, then we're going to equate to a volume of 0. So each of these needs to be greater than 0. So let's solve what that would mean. Well, in other words, we need x, okay, that's our first one, to be greater than 0. We also need 30 minus 2x to be greater than 0. And we need 60 minus 2x to be greater than 0. We need all of these to be greater than 0 in this question. Okay. So x is 0. Let's move the other one over. We get negative 2x greater than negative 30. And when I divide by a negative, our sign is going to change, so we get x is less than 15. And in the other one, we're just going to get x is less than 30. Okay? Well, because these two are kind of pointing the same one, we take the one that is least. Okay? Because we know that we need x is less than 30, but we also need it to be less than 15. So because that one supersedes 30, it is less than 30. Our two parameters are between 0 when x is greater than 0 and when x is less than 15. Because we know if it's greater than 15, we're going to end up with a negative volume in here. So that's why this one kind of doesn't fall into play. So our parameters are x between 0, or x greater than 0, but less than 15. So to find our parameters, again, we set up the question, we set the volume or the area in the previous question equal to 0, and we find our two parameters for it. So these are our intervals of our graph, the lowest and highest points. Again, we still need to figure out what our turning points are on this graph. So let's go back up to here. I'm just going to move down a little. Our volume equation is still our height, which is our x, times our width, which is 30 minus 2x, times our length, which is 60 minus 2x. We need to expand and simplify this. So this becomes 30x minus 2x squared multiplied by 60 minus 2x. And then we FOIL that. We're going to get positive 4x cubed. What is 60 times 30? 1,800 plus 1,800. So I've done those ends. Okay, let's keep track of what I've done. This and this. Now let's do that and that. That's going to give us negative 60x squared. And this will give us negative 120x squared. So when we go to simplify this, 4x cubed minus 180x squared. That's right. Okay, good. Plus, oh, there was an x here. 1,800x. So there's our volume equation, or yes, there's our volume equation. And it's volume in terms of x. Continuously forgot to write that, sorry. In order to find turning points or slopes when they're 0, we have to derive this. So we're looking at v prime x. When I derive this, I get 12x squared minus 360x plus 1,800. Okay? I can take out a common factor. I can take 12 out, 12, and we get x squared minus 30 plus 150. Okay? We're taking out our common factor. And remember, we're looking for when the slope is 0, so we're going to set v prime x equal to 0 in this question. Well, we can divide both sides by 12. We're going to be left with just x equals x squared minus 30x plus 150. Okay? Now, I can factor this. But what's going to end up happening when I factor this is we're not actually going to get factors at work. So, if we don't have factors at work, how do we solve for x in a quadratic formula? Quadratic question. Give question answer away. We use quadratic formula, okay? So in other words, we're looking for x is equal to negative b plus or minus the square root of. I know you're hoping you were done with this years ago or last year. b squared minus 4ac divided by 2a. Okay? Recall that this is our a, this is our b, and this is our c term. Plug it into quadratic formula. X is going to be equal to negative 30, which is just positive 30, plus or minus the root of negative 30 squared. Anyone know? 900. Good. Minus 4 times a. Negative 4 times a. Well, a is just the number 1. So negative 4 times a is negative 4 times 150 is 600. So we're looking at negative 600, all divided by 2 times a is 2. X equals 30 plus or minus the square root of 300 divided by 2. Again, because we're square rooting something, we're going to get 2 answers. So this is where we kind of split our quadratic. Just like when we were factoring, x will be equal to 30 plus the root of 300 divided by 2. And x will be equal to 30 subtract the root of 300 divided by 2. X ends up being, instead of carrying this out, I'm going to look for it. Approximately 23.7 and 6.3. So if you carried out those calculations, those are what you would have got. Approximately 23.7 and approximately 6.3. Okay, great. We got 2 answers. We have 2 turning points. What were the parameters of this question? We had to be between what 2 numbers? 0 and 15. So because x had to be between 0 and 15, we can technically say equal to. That's supposed to go there, not on the 0. That means this answer is not within our parameters, not something we need to use. So, the numbers we need to use in order to find out the volume, okay? In order to find out the volume and the length and the widths in the end, we need to find our volume in terms of x, which was 4x cubed minus 180x squared plus 1800x. We need to find them such that x is equal to 0, 6.3, and 15. Okay? We know that our 0 and 15 are going to produce what volumes? 0. So logically, we don't use those because we're trying to maximize volume. So we're looking for the volume when x is 6.3. So in other words, the height of this is 6.3. So we plug that in. I'm going to go on the assumption that you are able to carry out these calculations. We're going to go right to the answer after this. Plus 1800, 6.3. Your volume ends up being, in this case, volume at 6.3 is 5196. Okay? And that is in centimeters. Okay? Centimeters cubed. So that's going to be our max volume. But recall, they asked us, what is the height? What is the width? What is the length? Well, we know height was equal to x. So the height was 6.3 centimeters. Width was our 30 minus 2x. Well, width then becomes 30 minus 2 times 6.3. Our width then becomes 17.4 centimeters. And our length was 60 subtract 2x, which means length is 60 subtract 2 times 6.3, which gives us a length of 17.4 centimeters. Nope. That was the same. 47.4 centimeters. Okay. If you multiply those all together, you should get approximately, because again these were rounded numbers, you should probably get 5,196. You might get like 5,195.9888, something like that, just as we round it, okay? But these are the widths, length, and height in order to solve this question. Again, ready? A lot of work, especially creating the question and staying organized.